Got another example on the board here. This happens to be the function that's given in problem 4 in the homework. It's an even number, so it's not one that's assigned, but I'm going to just use this example. And I'm going to use it several times throughout these video series, so I'm not following the directions, but I'm stealing this function. And I want to just practice finding all of the critical points. If you want, go ahead and pause the video, try and work that out on your own, and then tune back in. Welcome back. So, if I'm finding the critical points, I'll take the gradient, which is just f sub x, comma f sub y. F sub x is going to be 3 minus 3x squared, and then the derivatives of the next two terms will just drop out because y is constant with respect to x. Partial with respect to y, I get zeros for the first two terms, but then I'll have negative 4y plus 4y cubed. Okay. Now, that is always defined, so I'm not going to get any critical points from the gradient being undefined, so let's see what would make it 0. So the gradient of f would equal 0 if both of these component functions were 0. So that means 3 minus 3x squared equals 0, and negative 4y plus 4y cubed is equal to 0. Here, that's 3 times 1 minus x squared equaling 0. That's 3 times 1 minus x times 1 plus x equaling 0. So x would equal plus or minus 1. Here, I'm going to factor out, a 4y. And that's going to leave me with y squared minus 1. And I just switched the order of the terms so I could write this in descending order. So that's 4y times y plus 1 times y minus 1. We're still wanting this to equal 0. So that's going to mean that y is equal to 0 or plus or minus 1. Okay. So I need x to be one of these numbers, and I need y to be one of these numbers. And that's going to actually give me 6 total points. So x could be 1 and y could be 0. X could be 1 and y could be 1. X could be 1 and y could be negative 1. X could also be negative 1 and y could be 0. X could be negative 1 and y could be 1. X could be negative 1 and y could be negative 1. So we have a total of 6 critical points right there. Now, in this case, when I was solving this system of equations, the two equations were sort of independent of each other. That's not necessarily always going to be the case, and we'll see that in our next example.